So a lot of the experiments that you've run have used our Marathon Match platform,
Yeah.
which is an algorithmic development and optimization platform.
Yeah.
And some of the stuff we've done has been things that you could basically call big data.
Sure.
Specifically, one of the research projects was around genomics data
Yeah.
in conjunction with Harvard Medical School.
Yeah.
And I've heard you talk about it a little bit, but can you just maybe give some color on where you see big data and open innovation from your experience as sort of a customer to these projects?
Yes.
How do you see that kind of synergy and where the kind of sweet spot is there?
Yeah. So we have run big data projects for both NASA as well as for the medical school.
Mm-hmm.
On the medical school side, and that was our first attempt at sort of a big data problem. And if you think about it, the Wikipedia question was also a big data problem as well. We were interested. What's happening in medicine and genomics is that there's an explosion of data gathering. So now they're doing these massive studies, genome-wide studies, where they're getting basically terabytes of data, of genomic data. And
so basically, genome processing is following the standard technology curve.
Exactly, Moore's
Every
law.
year
Exactly,
you're doubling the amount of genetic data you can capture.
Exactly, and then you have
the
to
speed they can capture.
Exactly, and then the question becomes, how do you analyze all this data and how do you make sense of it? So we had a colleague. Some of my work is with the medical school, where they have an initiative called Catalyst, which is part of an NIH-funded Center for Translational Research, which is trying to basically move innovations at the bench level, at the scientist bench, to the bedside. Right? There's a valley of death between what gets discovered in the benches of scientists to what gets actually to the patients. So the Catalyst program at the medical school is geared towards helping bridge this gap.
Crossing the chasm for
Exactly.
medical innovation.
Exactly. And this is a major issue because there's all this great research being done, getting lots of big data, but no way to analyze it, no way that you transform it into a useful solution that can actually be provided for treatments or for patients. And so we did this study where we were basically in the end trying to discover an immunomics problem in the immune system of people by looking at genetic data. And we wanted to basically look at mutations and predict the initial sequence and the structure for the mutations along the way. It's called edit distance, to be technical. We ran a challenge on TopCoder where we basically had about 1 million sequences, and we wanted competitors to be able to write code that would basically minimize the edit distance and predict the original mutation.
To be clear, there was already an algorithm.
There's already an algorithm that exists. Yeah, so the NIH.
So we're trying to optimize this.
Exactly right, and the NIH has built up an algorithm called MegaBlast and so on that try to solve this problem. The researcher we had that we worked with, he also had done his own research for about a year. PhD trained from Oxford, really smart guy, built his own algorithm as well. So we had 2 benchmarks available. And we said to the TopCoder community, well, we've got this problem. Can you solve it as well? And we want you to, accurately come up with the right distance at a distance that we care about. So improve the accuracy, but also do it really fast. And we wanted it done in a way so that you could actually process this data on a laptop computer instead of a cluster, basically. So we ran the challenge again. It was a 2-week-long challenge, 10 days or 2 weeks, I forget now. I think we had about 600 people register, about 122 people actually compete. We received 600 code submissions over this time period. And basically the top 30 submissions were an order, I think 1,000 times better than the gold standard from the NIH, and 100 times better than what the researcher had done. So the accuracy was better than what the gold standard algorithms were doing, but what was really phenomenal was the processing time. We basically went down to less than a minute, versus the researcher's algorithm. The original researcher's algorithm was going to be in the hour range.
And for the researcher, that's like
it's a huge. You just can't.
A different world.
It's a different world, right? It's a different world. And what it does, and so let me just say the data, right? So we were less than a minute for the top performing algorithms on TopCoder, done in 2 weeks time. About an hour for the researcher, and then about a day for the NIH algorithms for MegaBlast. Now, why this is important, because now if you can actually provide tools that can actually process all this data, you can actually ask bigger questions. You can actually go out there and think of different questions to be asking, which you just can't do with these types of other
So you
processing
move
times.
into new problem domains.
Exactly.
It's not just new solutions to existing problems. It's whole new
Exactly. And this is the promise of marrying open data problems with big data problems with open innovation.
Right.
Because in many settings, in many firms, what is going on is that people's ability to ask questions is limited by the tools and solutions that they already know that they have, and in many cases,
That's the poster you have on your door.
That's right. That's right. And so if you're not asking the right questions, you're not going to be able to come up with great answers. But people's ability to ask questions is constrained by the answers they already know, or how to get those answers.
The tools.
The tools that they have. And so what we're finding in our research around big data is that people often don't ask the big questions because they don't even know what to ask.